Okay, welcome to Math 135, Section 1.3, and I will leave you to read the purpose on your own. We're going to get started with the notes. So here in the Need to Know Schlegel Notes Part 1, we have something that I have found over the years to be confusing to many students, and that is the formula y equals mx plus b and the formula f of x equals mx plus b. And people often wonder, what is the difference between these two formulas? And the answer is that there is no difference. They are exactly the same thing. It's just that for some reason, somewhere along the way, people decided that it would be a good idea to replace y with f of x. Again, we can use them interchangeably, and they are exactly the same. The only benefit to the f of x is that it tells us what value to put in for x. And so, for instance, if we have f of 5 equals 3x plus 7, that would tell us that we need to be putting a 5 in for the x. And so here we would have f of 5 equals 15. Well, let's not skip steps. 3 times 5 plus 7. F of 5 would be 15 plus 7. And so f of 5 is 22. What this says is that when x is 5, when x is 5, y is 22. And so it's kind of an interesting way of interpreting that, but that's one way that we use it. And so if we were to graph this, or this is a point on a grid, this would be the point 5, 22. Similarly, with y equals mx plus b, if we put 5 in for x, we would get y equals 3x plus 7. And again, I'm just making up this equation for an example. So we've got y equals, again, if we're going to put 5 in for x, we would have 3 times 5 plus 7. Y equals 15 plus 7. Y equals 22. So here again, we see that the y value is 22, just like we did on the one on the right. But the disadvantage of using y instead of f of x is we don't know, just by looking at that last piece, what the x value is. And so again, over here, we can see that when x is 5, y is 22. And all that we can tell by looking at just this piece is that y is 22. We would have to go back up here to see that x is 5. And so that's really the real reason for using that notation. We call it function notation. And again, y and f of x can be used interchangeably. They do have the same meaning. The only benefit is that we can see both the x value and the y value at the same time in our solution. Okay, I hope that sets you up for success with certain things and maybe removes some confusion that you've had in the past. We'll be using both of those interchangeably throughout this course. Moving on to the next little dash there, we do have the slope formula. And so I'm just going to, again, make up an example here for us. So let's say that we were given 2 points. And we had the points, oops, I do not want a highlighter for this. There we go. Well, let's say we had the points, my gosh, there we go. Let's say we had the points 3 and 7. And the point -2, -8. And I'm actually going to make it so that this 7 is negative and this 3 is negative. So I'm going to make them all negative for a reason. So the slope formula, again, if we're trying to find the slope of the line passing through these points, would be y2 minus y1 over x2 minus x1. Now you'll see me doing this a lot because frankly I get confused and lost if I don't. I have to mark personally my points. So that's going to be my x1 and y1. That's going to be my x2 and my y2. And this helps me not get confused as I work through putting those things where they're supposed to go. One more thing that I super highly recommend you do is when you do the slope formula, draw your fraction bar and put your minus signs in. And I'll get to why in a moment. And over here in blue, I'm going to show you the common mistake that students make if they don't put the minus signs where I just did in the black example on the left. So again, my y2 is -2. Nope, that's my x2, my bad. My y2 is -8. See why it's important to label your points up there? So -8, my y1 is -7. And my x2 is -2. My x1 is -3. And so you'll often see math instructors and things like this putting parentheses around this second number. If you choose to do that to keep those negative signs separate, that's totally cool. It's not something that I'm fussy about. So you may see instances where I don't do it, not because it is the proper thing to do, but sometimes I'm just not being fussy about it. So again, the black example is done correctly. The blue example is what most students do incorrectly when they do this, if they do not put the minus signs here to start with, like I recommended. Here's what will happen. They will say, gee, y2 is -8 and y1 is -7. And x2 is -2 and x1 is -3. And I'll pause here for a moment for you to see the difference between the black example and the blue example. Again, the black example is correct. The blue example is not. The mistake that these people made was that they forgot that we were subtracting these x values and y values in the formula. And so when we have a negative value that goes on the right, a lot of times people forget to write the second negative sign. So again, my example, and I'm going to do it over here in green this time again on the right. My recommendation anytime you're doing the slope formula is you start with what I wrote in green on the right, and you put those minus signs in there before you ever put a number in. It just helps you not to make silly mistakes. All right, so for this now, I'm going to go ahead with the black one since it is done correctly. We have -8. Those signs are going to change to be a +7. -2, again, +3. And you could totally swing this in Wolfram. I'm actually going to do that right now. I did want to just sort of show that by hand a little bit, but getting good at Wolfram is going to be something that's going to help us out a ton. So let's pull our buddy Wolfram in here. And the way that we're going to enter this into Wolfram is we're going to have to put things in parentheses so that the entire thing ends up in the numerator of the fraction. We will have -8 minus -7. Close my parentheses. In the denominator, I will have -2 minus -3. And I'll zoom in on this a bit. So again, that's how we're going to do that. There are 2 minus signs right there, and there are 2 minus signs right there. I believe that Wolfram will interpret that correctly. There we go. So see how it shows both negatives there, or the minus a negative and minus a negative. We end up with the result of -1. And so again, I'm not a person that's going to do a whole lot of math by hand in this course. You could have totally completed this by hand if you wanted to. I really wanted to take the opportunity to show you how to do it in Wolfram, which is what I would sort of expect you to do from now on. But we are going to get -1 as the result for the slope of the line passing through these 2 points. And rounding out this section of notes, we are going to discuss the idea of the next bullet down, which is slope-intercept form, y equals mx plus b. Hopefully that is something that you feel very familiar with, where m is the slope and b is the y-intercept. And so let's jump over here and just kind of take a quick jot at writing that down really quick so we make sure we got that. So for y equals mx plus b, again, hopefully this is something that you're very familiar with. The m is the slope. People also call that the rate of change. And the b is the y-intercept. Another word for that is often used is the initial value or the start. The next one down is a fun one. Most people really don't like it, especially if they have to do it by hand. For us, it's not going to be that big of a deal because we will have Wolfram doing it for us. This is going to be point slope form. And again, this one above it was slope-intercept form. Point slope form, everyone, is like this. It goes y minus y1 equals m times x minus x1. And the interesting thing about this one, everyone, is that the m is still the slope, and that the x1 and the y1 together represent the coordinates of a point. So for us to be able to use point slope form, we need the slope and we need a point on the line. For slope intercept form, we need the slope and we need a specific point on the line, which is the y-intercept. In the next slide, I'll be talking about how we really prefer to use slope intercept form as much as we can, but that we are sometimes stuck and have to use point slope form. We'll get to that more in the next slide, though. That's going to be it for the notes for this piece. I hope this is helpful, and we'll be back with the next one shortly.